Hi, I'm Jean-François. Andy, if you want to participate. I was not expecting you in the meeting, but
no, that's fine.
Yes, so I will try to be quite brief because I ask participation from our colleagues and I received so many slides that I have to filter out, and we'll see how I can perform. So ESRF in a nutshell, this is a synchrotron like DAISY. It was presented before. We are an international collaboration of 22 countries, partners. This is the new generation of synchrotron with low emittance and high energy. We operate 47 beamlines, and something that I want to insist is the diversity of techniques. We have more than 100 and 120, something like that, different scientific techniques, from microscope to tomography and this has some consequences. We have a very diverse scientific community, from energy, material science, up to the cultural heritage. And more or less, we are running 2,000 experimental sessions per year, which means many more experiments in practice. ESRF is very lively. We have new beamlines and new equipment, more or less, for sure every year, and quite often every month. And this is just some news presented there. That's all for the ESRF. Now, in terms of before entering into more detail in the scientific journey, I would like to present the workflow. So it starts, like that was explained by Daniela, by proposal submission and a review, the selection of the proposal. Then there's the sample preparation, shipping, the experimentation, then the data processing, the transfer of the data management, and at the end, quite often, and we expect it, scientific article. So more or less today, all these steps could be performed remotely by ESRF users. This has some consequences, but basically they can do it just using a web browser. And I will enter a bit more into the detail. So if we talk about remote, we have to talk about the pandemic time, and the reaction we had at that time. It was a surprise for all of us. We were working on remote monitoring, remote acquisition, but here we had to provide a generic solution if we did not want it to stop completely the ESRF. So I will present these solutions, but basically from the point of view of the user, it needs a large screen where, yeah, I don't know if you see my pointer. There is an access to the machine of the beamlines, remote access in a web browser. And we set up also a video conference solution to allow discussion between the scientific staff that were located on the beamline and the user team remotely. So this generic solution for accessing the desktop of the beamlines machine, we had to interface this with our proposal system, to interface it with the planning of the beamline, and to keep an authoritative access control from the beamline staff. This solution is based on Guacamole, which is an open source solution, and currently this is open for all the beamline since September 2020 when it came into production. The solution for a video conference, we placed a device provided by a company called D10 in all beamlines, and they have a direct link, so users have a direct links to the beamlines if they want to discuss with the people on site on the beamline. But before the pandemic, we already had some tools. They were introduced by the talk of Andre. So iSPI-B is the LIMS, the information system for the MX beamlines, and it has been developed long time ago. So this is in production since 2004 now. This is a large collaboration, and this tool basically allows to automate the sample tracking and provide the monitoring of the experiment. So this is in place for the MX beamline, but also now for different type of beamline like BioSax and the microscopy. beamlines. Alongside iSpy-B, there is another tool which is more focused on the acquisition, to control the experiment and perform the acquisition. This is MXCube, and this is interface with iSpy-B, so the users can fluently move from one to the other. This is also a collaboration with 15 partners that started years ago as well. And it is now in production. This is specific to the MX beamline, and it is in production on the 6th MX beamline at ESRF. So this iSpy-B and MXCube are focusing on the MX, not only, but focusing on the MX, and are very convenient solution for users of this type of beamlines. But now we are looking for something more generic, something that could be used by other beamlines. This is called daiquiri. And this is a system where the people could perform the remote experiment, and in particular, the acquisition. So the interface is relatively simple. It's accessible to novice users. And if you want to see it in action, there is a YouTube video from one of the experiments that was performed at the ESRF, where you can see how powerful this is. So on top of the acquisition, there is a complete monitoring. So what you see here is all the devices which constitute the microscopy beamline ID21. But basically, you can identify or monitor or act, depending on your privilege, on any of these devices. So in terms of concept, users logged in. This is a web interface, and some part of the tool is limited for the staff beamline. So in a way to avoid the crash that was demonstrated in the talk before. And it automatically enforces the data policy. There could be multiple sessions, but only one has the control of the beamline, and the staff can always take over the control. There is also a queue mechanism for automated the beamline during, for instance, the night. In terms of deployment, currently it is deployed on 7 beamlines, very different ones, spectroscopy, tomography, and 4 new beamlines are in the pipeline. So this was for the acquisition for the experiment. The team has developed also, the data at ESRF are all in H5, HDF5 file format, and sometime until now, most of the tools for visualizing the data were local tools to PC. We have developed a complete web environment. This is a sort of toolkit library that could be integrated in any web service, web application, and this is what we have done at ESRF. This tool has been very popular. You can see on top the number of downloads, and you will see it in many, many different tools. If I move to the data, we have a data catalog. So all data during experiment are recorded in the data catalog. You can search this data catalog. There is also, and I will show it just after, an electronic logbook. We mint DOIs for all this data, and we try to be fair as possible. So lots of metadata, administrative and scientific, technical, are recording in the data catalog. The logbook, quickly a view on the interface. So the idea was to replace the paper logbook to something that could be hacked and shared remotely. A very complete logbook now. The data portal, again, I will be quick on this slide. This is the result of a collaboration. It was led initially by STFC. Now there is different partners inside. You have the link. So for the download of the data, we produce from time to time very large data sets that could be up to the largest one is probably something like 100 terabytes. Users were using disk, and they were moving, when they were on site, they were moving the data on disk, and the bag of disk was used to transfer the data to their home lab. So we had to move to a solution, it's called Globus, that allow very large transfer of data reliably. And this is in place since autumn 2021. And most of the people have very positive feedback on this one. If I move to data processing, data analysis, we are using Jupyter, not for all experiment in all cases, but we are pushing for the use of Jupyter. And we set up a tool, it's called Jupyter Slurm, that we set it up on top of our cluster, on a Slurm cluster. This is available for the users during 6 months after the experiment. And it's quite used with more than 150 users per month. We are also deploying, and we are currently in the deployment of another tool that has been developed in the scope of the PANOSC project, which aims to provide dedicated VM to the users. Quite often, all the algorithms and libraries are not available in, couldn't be used directly into Jupyter. We have lots of legacy software. And this is a solution for the users. So when they ask for a VM, they can do it themselves. They will get access to the data. They will get access to scientific software, and they also get access to resources. So typically GPUs, HPC cluster from there. This was developed by the colleagues from ILL in the scope of PANOSC. This is my last slide, and I would like to reflect on the challenges of remote access. One of them, and especially because with the COVID, we had to go full remote very, very quickly and provide solutions which are not necessarily the best solution in terms of cybersecurity. So we had some constraints. We really needed to get rid of generic accounts. And even for the normal account of the users, we have some difficulties. It's not rare that users share their username and password, share their credential, which was not happening before. To enter ESRF, there was a passport vetting at the site entrance, like in many other research infrastructure of this size. Now we have to replace it by something else. As we expose the software to internet, we need to be very careful on the updates. Previously, when they were on an intranet with few people able to access it, we could be quite relaxed on the updates. Now this is not anymore the case, and there is consequences on the cost. We have to reflect also in terms of software architecture. This is absolutely not the same as again, as developing a software that will be used on a single PC or software that will be exposed to intranet. So network segmentation and filtering on the local network. We have a lot on cybersecurity, and we are just at the start. The remote access has also some consequences in terms of cost. I explained the need, the real need for the software maintenance. Obviously, there was the development of this software, but also in terms of IT infrastructure. As the services are exposed, we cannot stay like we were working years ago. In terms of cost also, there is a lack of local support. It was not rare that during the night, the users took the shifts, which is not the case anymore. So if we want to continue to work 24 hours a day, we had to recruit some scientists to perform to help performing the experiment locally. Everything, so typically sample positioning and things like that, currently everything is not possible remotely. I would like to insist on the technical collaboration. You have seen a part of the tools, but there is, as we have so many different techniques, we are relying on a large number of tools. And in order to reduce the cost, we clearly have to foster collaborations. The needs are probably the same in other research infrastructure. And this is a key point. Also for the users are moving inside the community from one ERI to another one. It would be much simpler for them if they have the same interfaces, the same workflows. An impact which is not clearly, which is not necessarily obvious, but this is the scientific collaboration. I'm not so sure that we have replaced the face-to-face discussion during night between the local scientists and the remote users. And there is need probably in the long run to replace if people are not traveling so much. That's all for me. I would like to thank my colleagues who participated in the slides. And there is also some complementary information if people are interested by the tools. Thank you.